Hello everyone and welcome to my presentation. My name is Mikko Mäkitalo and I'm a doctoral researcher in University of Oulu, Finland. The topic of my presentation today is convolution method for reconstructing classical soundscapes. Senses and spaces. Sight has long dominated the research into the spatial design of ancient Roman housing. What we are doing in our forthcoming research paper is that we are challenging the dominance of vision by bringing in the auditory sensations too. As we all know, space is not configured only by sight, but also by other senses. And in our research, our aim is to recreate the soundscapes of two ancient buildings, which one of them is located in Herculaneum and the other one is located in the ancient ruined city of Pompeii. And our main research question is how acoustics affected the use of space. So we decided to use a convolutional method for data collection, and especially we wanted to use a binaural convolution method. And this is something we have already used in our initial tests, and this is also a method that we will use in our future work too. So what does binaural mean? Binaural means that it's some audio, that is mimicking how humans naturally hear sounds. Meaning that it has the exact information of where the sounds are coming from. So when you hear binaural sound, it has a very strong sensation of the direction where the sound is coming from or where the sound source is. And convolution is a standard digital signal processing method. And convolution means that two signals, and in this case two audio signals, are combined, one could say intertwined, in such a way that the first signal is, for example, a so-called dry recording that has been made in recording studio. And the other signal is a so-called impulse response. And impulse response means that it's an audio sample that contains the acoustic properties and acoustic conditions of a certain space, a space where the impulse response has been recorded. And convolving the two signals means that the result sounds like the first signal that was, for example, speech in studio would have been recorded in the place where the impulse responses were recorded. And to capture a binaural impulse response, you have to use certain kind of audio technology and audio equipment. And we have used a Neumann KU100 microphone, and we have recorded impulse responses in 3 locations. And those 3 locations have very different kinds of acoustic conditions. The first one was in a forest in Oulu, Finland. The second one was an office room at our university. And the third one was a wooden church built in the year 1694. And a commercial plugin has been used for convolution so far, but we will have our own convolutional computer program in the near future. Work is in progress. And by using our own computer program for convolution, we have very delicate control over like every parameter of the convolution signal processing method. So we have done those initial tests in 3 sites, and all of them have been very successful. And we have used pre-recorded audio signals, for example, speech and grand piano playing, to do the convolution with the impulse responses. And here you can see an actual photo of the KU100 binaural microphone that looks like a human dummy head, and also a loudspeaker. And in the picture we are in the old wooden church I mentioned before. And now you will hear a short example of the convolution, and in those audio clips we have used grand piano playing, and the grand piano was recorded in a studio, and it's a Chopin Polonaise in C sharp minor, or like a little clip of the introduction of it. And here you can see the original so-called dry signal without any additional effects. And here's the convolved version of the same recording, exact same recording, and this time it has been convolved with the impulse responses of the old wooden church. So I hope the latter audio clip gave you an impression of a larger hall, a larger room, like wooden church-like feeling in it. So what are the challenges and what is our future work? One huge challenge is that when we will import this convolutional method into a digital twin, for example, Unreal Engine, how to interpolate those impulse responses in a digital twin so that the one who experiences the space in a digital twin or in virtual reality could hear those binaural impulse responses correctly. And machine learning will be used for interpolation. And another challenge is how to recognize the direction of sound by digital signal processing from the phase and amplitude features of audio signals for training the machine learning model. So that kind of data would be used for training the machine learning model. And this is not a challenge, but it's like part of the future work. So we will import visuals too into a digital twin, and so create an immersive audio-visual experience that could be used, like this method and methodology could be used for dozens of kinds of it has a lot of applications. So in the future, we will apply the binaural convolution method of ours to several places in Finland, including Turkansaari Open Air Museum church in Oulu and another church in Seurasaari Open Air Museum in Helsinki. And there will also be a new project in collaboration with church historians. Also, it is known that people of different social ranks had different auditory experiences. For example, in a church back in the day, where their seating position was based on their social rank and their socio-economical status. We will do the research case studies and tests in Finland first, and then we will move to ancient sites in Italy. And here we have two pictures of House of Wooden Partition in Herculaneum, the third, 11, and these pictures are based on LiDAR scans, so they're like laser scans. And here we can raise the question like how auditory and other sensory cues affected the use of space. And for instance, was there an acoustic difference between rooms that have been identified as bedrooms? And here are some selected references from the field of archaeology and signal processing. And so, thank you everyone for watching and listening to this presentation. The topic of my presentation today was a convolutional method for reconstructing classical soundscapes. And my name is Mikko Mäkitalo, and I am from University of Oulu. And if you have any further questions, any comments, any suggestions, or like anything related to this topic and this presentation of mine, feel free to contact me via email. You can see my email address here on the screen. So, thank you and goodbye.